good afternoon, good morning, or good evening, depending where you are. Okay, I'm Ciro Gardi. I'm scientific officer at EFSA, at the European Food Safety Authority. And Monia?
I'm Monia Lombardo. I work as a research engineer at the IT Institute in Austria, but I've been working for EFSA as a trainee and later as a consultant.
Okay, so I think I can start, and we will present briefly the activity on commodity risk assessment of plants, mainly plants for planting, but not only, that is conducted by EFSA for the product imported into the European Union. So we will go through a bit, let me, something is, okay. Here we have the outline, so we will start with an introduction on the relation between globalization, the increasing in movement of goods and people, and the increase in interception and outbreak of invasive alien pests. Okay, of course, this may be well known by most of of our audience, but I think it can be anyhow useful to discuss a bit, present a bit on this, and then I will present the part related to the evolution of the plant health law in the European Union and how this brought to the initiation of this commodity risk assessment for high-risk plants. And then we will go deep into the methodology that is used for conducting this commodity risk assessment, and Monia will present this, and also an analysis of the 5 years of data that we have collected so far. So let me start with this link between globalization in a general term and the invasive plant pest. So the relation between these two processes is very well known, and we know that trade in general in the last decade, I would say more than 1 century now, has been always increased, steadily increased, I would say probably in the last 2 centuries. And with the trade, humans are moving a huge variety of goods and also moving people. But the movement of plant and plant material is the major pathway for the introduction of plant pests and pathogens. Plant pest, let's use pest as a generic term that include, of course, arthropods, but also pathogen and so on. So it's the main pathway for the introduction of these organisms in new territories. So in this graph that on literature there are a series of analyses carried out. This is one quite recent paper published in 2025, and there is an interesting analysis showing how, if we consider the historic time, let's say starting from the 19th century, because before that we do not have data, but starting with the 19th century up to today, this curve, let's say bluish purple curve that has 2 peaks, represent the variation in the invasion rate. And we can see clearly that, so the red horizontal line means if we are above, we are in a situation of increasing introduction of invasive alien pests. If we are below, we are in less than the average. So essentially, we have two peaks. The first peak is still at the end of the 19th century, and the motivation, the cause of this increase is in relation to, you can see below there are some symbols that indicate what was happening. They show what was the main innovation of that period. And we know that in this period, let's say, during the 19th century, the shipment, the big boat, the ship, started to be powered not anymore with sail, but with the steam engine. And this increased enormously the potential to the speed of transport of goods. And so there was a dramatic increase of transport even at that time. And so to this, it corresponds this first peak. Then why the process decreased? Decreased because due to a series of even technological or sanitarian or geopolitical events. So in this period where we are below the red line, we had the First World War, we had the Great Depression, we had the Second World War, and then soon after the Second World War, the rate of introduction of new pests as well as the trade increased at a rate that was even much higher than before. And one innovation that made this so dramatic was the introduction of containers for transporting goods. The introduction of containers is considered to be at let's say, the main driver of globalization, because the way of transporting goods changed in a dramatic manner. So it became much, much more efficient. Showing another interesting image with these four maps referring to four different periods from the same paper, we can see in which part of the world, in which countries, this introduction of invasive alien pests has been high. And the first period before the 1900, it was essentially North America and with a lesser degree Europe. So we can say that the Western countries. And this has a clear relation with the average income and the fact that most of the trade were coming from all the rest of the world into these countries. No? The second period, the situation is essentially the same, but we can see that some countries are growing up, like China. No, the economy is not like it is now, but several countries start to increase in trade, in importing goods also, and so in parallel also the introduction of pests. The period that go from the 50 to the year 2000 show that also other part of the world, also like Latin America, Australia, in this area too, there is an increase in introduction of pests. And on the current period, we can see that all the developed economies experience a quite high rate of introduction of species. It's interesting to analyze, and these are data from Eurofit. Eurofit is the database that was used in Europe, is still used, but now there is another system in place for the interception. So in this graph, what we can see is that, okay, the column represents a different geographic area where the pest that has been introduced in Europe are originated. But the row represent which type of commodity is responsible of most of the interception of the introduction of new pests. Sorry, interception, not introduction, because not all the interception result in outbreaks, of course, luckily. What we can see that the larger is the circle, means the more important is, higher is the number of interception. And the white color represent fungi and the black color represent insect or arthropods more in general. So one aspect is that arthropods represent the majority of the interception, also because probably they are more easily intercepted. And then what we can see that the commodity that represent the main pathway are plants for planting, wood packaging material, and fruit and vegetable, essentially. So this is an analysis conducted in the period 2016-2020. But if we analyze a similar analysis conducted in another research paper from Rosace et al. That refer to a different period, indicate essentially the same. So this highest column indicate the plants for planting, bonsai, aquatic plants, and carnivore plants. These are very strange commodity, but overall, plants for planting represent, it has the highest bar. The other relevant pathway are, again, the wood packaging material and also fruit and vegetables and some other with the lower values. From the same paper, this analysis showed the temporal evolution of interception. And from this, we cannot see a clear trend because we have a kind of up and down. And the colors represent the interception in the different country. There is not a clear explanation of this trend. Not really trend, is really not homogeneous variability among the different years. We have to consider that in this period is covered also, at the end of this period, this decrease can be related, because the last year is 2019, can be related probably also to COVID. But coming to the topic of our presentation, we all know several examples of pests that has been introduced. And here I'm reporting a few examples of some of the most, let's say, impactful pests that has been recently introduced in Europe. So we have the red palm weevil, we have the pinewood nematode, we have the dramatic case of Xylella fastidiosa, that probably for the last decade is probably the most is the pest that has caused the highest impact so far in Europe. But we have several others. These are just examples: Popililia japonica, the Maconellicoccus hirsutus, Anoplophora glabripenis, just to mention some of them. And of course, all these, let's say, crises raise attention to also to the public opinion in Europe, and Europe decided to change, to amend the legislation, not only the legislation, but all the phytosanitary system to be more, let's say, protective. So here now I will move to some slide describing what has been changed in the plant health legislation in Europe during the last, let's say, two decades. So the European Union so far, contrary to the vast majority of other countries, was essentially has been and still is an open system. So the import of goods is generally allowed as long as there are no evidence of risk. So if there is evidence of risk, the Europe can pose a ban or limitation. Most of the other countries in the world use the opposite approach. So there is a ban of import unless it is proven that importing a given commodity is without any risk or with reasonable risk, let's say. This change has been translated in a change from in a transition from the Directive 2029, that was the plant health law in force until 2019, to the regulation, European regulation 2031 of the year 2016. So as you know, probably between the time, so 2016, when has been published the regulation or a directive, and the entry in force of the same regulation of directive, there is a period that is generally 2 or 3 years. Also because then the member state should adopt this legislation if it's a directive. If it's a regulation entering force directly without any further legislative process at the member state level. So what has been changed? Before there were certain restrictions, so the system was open, and there were few permanent prohibitions, like for instance, the import of Solanaceae plants was prohibited and still is prohibited. The new system still have certain restrictions for the import of some goods. Still there are some permanent prohibition, but there is a new category. So this provisional prohibition pending risk assessment. So this is the most important change that has been introduced in relation to commodity risk assessment. So this is the regulation that I mentioned just in the previous slide. And as you can see, there is a specific article, that is the Article 42, that gives a definition of high-risk plants. So this article lists a series of plants and plant products at the genus level mainly, that whose introduction pose a pest risk of an acceptable level for the EU territory. So I don't know in detail, and we can enter in discussion how this pest plant genus or species have been selected, why some genus yes and other not. This, I have to say, I have to be honest, is a process that I don't know in detail, but it was the result of course, scientific evaluation, but also mediation between the different interests of the member state that compose European Union. As you can imagine, for the southern countries, southern member state of EU have interest in protecting some crops that are very relevant for them, like the citrus or the olive or the vineyard, while on the contrary, the northern country have interest in protecting. There are other crops and other crops or even species in natural ecosystem that are more relevant for them. So the overall process was the result also of negotiation among scientific evidence and negotiation. In addition of this Article 42, then it was necessary to, with the two implementing regulation, to list exactly which plant genus should be evaluated, and in another implementing regulation is defined how the commodity risk assessment should be conducted. Here you can see the list of plants or plant products. At the origin, there were 34 genera and 1 species of plants for planting. So the majority were plants for planting that has been regulated. Then there was one plants in a form of reproductive material, in form of tuberous. No? The species is Ullucus tuberosus, and what was regulated was the tuber of Ullucus tuberosus. And then there were fruits of Momordica. And in this case, Momordica was regulated only with specific attention to one pest, that is trypspan. Below here, you can see the list of the genera that has been regulated. And so the overall process is described here. So we have the list of these high-risk plants that are indicated in this implementing regulation, 2018-2019. We have another implementing regulation that defines how risk assessment should be performed. And then the decision, as you probably know, is taken by the European Commission. So in Europe, there is a distinction between the risk assessment body, that is European Food Safety Authority, is EFSA, and the risk manager, that is European Commission. So the EFSA performed the commodity risk assessment based on the dossier that has been sent by the applicant country. Just to make an example, let's imagine that Australia would export plants of malus to Europe, so should prepare a dossier where everything is described. But Monia will explain this more in more details. Okay, I try to speed up because there are a lot of things to be tell. In addition to the commodity risk assessment for high-risk plants, EFSA started also to do commodity risk assessment for some specific derogation request that has been received. This derogation request refer to plant or plant product that normally are prohibited, are permanently prohibited. But based on the specific request by some country, the Commission can evaluate the possibility to open, to lift the ban for based on this specific derogation request. Also, in this case, a commodity risk assessment should be performed. Here you have some example of derogation request that has been tackled by EFSA using the same approach, the commodity risk assessment approach. I will skip these two slides because there are numbers that you can have later on and you can reflect. These are not preliminary, are some data in relation to which one of these high-risk plants have registered the highest number of interceptions. So, and here are the taxa that were more intercepted. So I leave this, I skip this, I go fast on this because otherwise we cannot complete on time. And I introduce briefly this because it's the last request that the Commission sent to EFSA, that is to perform. This is a request from the Commission, so it's not based on application from third countries. The European Commission requested EFSA to perform a commodity risk assessment on asparagus pears. Because, why? Europe is producing asparagus and consuming asparagus, but the production period in Europe is only from more or less April or end of March till June. For the rest of the year, to have asparagus on the shelf of the supermarket, this product is imported mainly from Peru, Mexico, but also Ecuador, Morocco, Thailand, and other countries. Here, is the story in brief. So in 2022, 2023, when at the interception on asparagus, there were frequent interception of Spodoptera frugiperda. This raised attention for the Commission that increased the rate of inspection on asparagus consignment. So moving from 1% of the consignment inspected to 100% of the consignment inspected. And this was a kind of loop because there were more inspection, but then in turn, many other pests were identified, many other interceptions. So not only Spodoptera frugiperda, but also other arthropods, other insect maybe. And so, based on this, the European Commission requested recently, in November last year, to EFSA to conduct the commodity risk assessment. So we have started this process, and these are the indications given by the European Commission. So we should do the commodity risk assessment for green asparagus, focusing on especially on quarantine pests, but also some non-quarantine pests, focusing on the pests that are more intercepted so far. And then the priority should be given to pests representing different taxonomic groups. Okay. This will be the process, but I can leave. This is the process that is normally adopted when we do commodity risk assessment. But I go quick on this slide because you will see a similar slide presented by Monia when she, in a few minutes, will present the methodology that EFSA adopted for performing commodity risk assessment. Monia, I think now, no, okay, there is this last slide on asparagus that show you essentially the supply chain of asparagus from the mainly Latin American exporting countries. Here is indicated the transport from airplane or ship, but 94% of the shipment is by airplane. And that's it. I think I give the floor to Monia for the...
Yes, thank you. I will kindly ask you to then, for each slide, when to change, because unfortunately I was having some issue with my connection. So, okay, on the following slide, as Ciro briefly discussed, I will present how EFSA conduct commodity risk assessment. So how CRA process starts. So the National Plant Protection Organization, so the NPPO from a third country, can request a lift of the import prohibition by submitting a technical dossier in which express their interest in exporting a specific plant commodity into the EU. The dossier is then sent to the European Commission, and this dossier is the basis of the risk assessment. Next slide, please. So once the dossier is sent to the EU Commission from the third country, this is forwarded to EFSA that will check its completeness and then perform the CRA. Next slide, please. What the dossier contains and how it is composed. The dossier is composed of 3 parts. The first part regarding the commodity data. That means how, when, and where the commodity is produced. And of course, for commodity, we meant as a certain part of a plant species that could be a cuttings, a rooted plants, a bulbs, a whips, etc. And the second part instead they should provide is about the pests associated to the plant species that wants to be imported. And they should point out those pests that might be relevant for the evaluation. The third part, instead, is about the phytosanitary measures applied by the third country to avoid the widespread of certain pests and to ensure a correct management inside the nursery. And this is a very important part because the mitigation measures, so the phytosanitary measures applied, are essential to support the assessment because basically correspond to what the third country and the nursery does actively in order to prevent the pest outbreaks. So they need to describe pesticide application, calendar, dose, active ingredient, rotation, target pest, agricultural management in general, and so on. And about the dossier content and how the dossier should be developed by the third country before being submitted to the EUCOM, it's published as a technical report, as you may see from the slide. And also 3 webinars are available to assist the non-EU countries, so the third country, for the preparation of their dossier, which can be found also on the EFSA website. And after the first evaluation of the dossier, if some information from the third country are needed, it is possible to send back the dossier to the NPPO of the requesting country with the request of additional information and clarification. Next slide, please. So, as said, the technical dossier is the basis of the CRA. And so all the information embedded in the dossier will be evaluated by EFSA staff and a board of experts that have been selected based on their expertise in the topic of plant pathogens, entomology, virology, nematology, and discipline linked to the plant protection. So all the pests associated to the commodity species will be screened, and an evaluation of their potential entry and spread on the EU is developed. And the pest selection process starts with the identification of all the pests that are potentially associated with the commodity species. And these are then selected as either EU-regulated pests on the basis of the EU Regulation 2019-2072 or as non-regulated pests. And each pest is subsequently assessed for its relevance. As you may see, relevance, yes, no. If a pest is considered not relevant, it is excluded for the further analysis, while if it's relevant, it is included in the list of actionable pests. And the relevance of a pest is determined based on several criteria. Those include if the pest is present in the requesting country, if the pest is already present and widespread also in the European Union in more or equal to 3 EU member states, or if it is strictly associated to the commodity under assessment. Like for example, if a pest is uniquely associated with roots of the plant species commodity, it's highly unlikely to be relevant for a commodity if the commodity, for example, is consisting of cuttings, or as the pathway for its spread would be highly improbable. Or as well as if the pest has not been reported to be present in the requesting country, there is no way that it can be exported from them because they don't have it. So in addition, if a selected pest is not classified as a quarantine pest, but has been selected for the criteria that I said before, it may be subjected to a further categorization steps. And this will be described a little bit later in the presentation. And next slide, please. So for each relevant pests, EFSA evaluates the likelihood that this pest is present in the nursery or at the place of production based on the information that can have been provided by the third country. In addition, EFSA assessed whether the risk mitigation measures applied by the third country are actually effective in preventing the presence of the pests. And based on this evaluation, EFSA estimates the likelihood that the commodity is free from that specific pest through how expert knowledge elicitation procedures, in brief, ECHE. And this process is repeated for each selected pests considered to pose a potential risks. And finally, the overall results is expressed quantitatively, as from the ECHE, in fact, providing an estimate of likelihood of pest freedom. And this output is described in the CRA opinion. After that, the European Commission, receiving the scientific opinion in the role of risk managers, as briefly was introducing also Ciro, will take the final decision on continuing or not the trade and in what condition of this commodity with the requesting country. And next slide. Yeah, a few words we can say about ECHE, about this methodology, if Ciro would like to introduce, or if it's Ciro, would you like to introduce the ECHE, or should we?
Okay,
To them?
we have added some. We have some slide on ECHE. There are quite some. I will go in the interest of time relatively fast on this, but this will remaining for the presentation to be shared. So ECHE is a methodology that is widely used in not only at EFSA, is used in many cases when it's not possible to rely on measured data. So ECHE, that stands for expert knowledge elicitation, is a methodology to systematically elicit the evaluation from the expert. So I have to confess that also when I joined EFSA and I was coming from a different type of activity, I was in academia first and then in another, the Joint Research Center in ISPRA. I have to say, from a scientist, but we are all scientists, thinking to a data that is not measured can sound a bit weird, no? Because as this slide says, the man say, but you want to use a subjective probability. This is not scientific, no? In reality, the aim is the objectivity, but there are, as we know, several situations where it is impossible to have measured. Let's imagine the case we were describing or the assessment we are doing, where we have to know how many pests can be present in an exported commodity. So measure this number is practically impossible. You should, in theory, take all the consignment, destroy them, and count all the possible pests that are present. So in these cases and in many other cases, judgment can be a solution, and it's not let's say, a workaround. It is a solution that, if performed in a scientific way, so avoiding bias, prejudice, and other possible error, can be really the best solution that we can have for performing evaluation and for providing element for to the risk manager for taking decision. This is important because, as you probably know, EFSA, also in PRA, in pest risk assessment, changed from the qualitative approach that was used and is still used by many countries, by many NPPO, to a quantitative system. So we are trying to express probability in numeric term, conscious that this number are characterized by some degree of uncertainty. the importance of the expert knowledge elicitation, that together with the estimate of the probability range, of the credible range, we are able also to provide an estimate of the associated uncertainty. So, for instance, this image is a jar full of beans. No? So a question can be, how many beans do you think that there are in this jar? And the question can be posed, is not posed straight away in this manner, but if this would be an ECHE, I would ask you, okay, first of all, I have to provide the information. No? So I have to provide what we call evidence dossier. That is an element that is essential for the ECHE. And then the evidence dossier provide you a lot of information, all the information that you can collect. So what is the volume of a bean? What is, I don't know, the volume of the jar? Several information that can help you in giving the correct estimate. Then the elicitation is not directly, tell me how many beans there are in the jar, but is tell me first the first percentile and the 99 percentile. So I ask you, what is the number that for sure cannot be lower than that? What is the number that for you are almost sure that cannot be higher than that? So this can be even very wide. I can say, okay, I'm sure that for sure there are not less than 50 beans, and I'm sure that there are not more than 1 billion of beans. So can be quite broad. And then I ask during the ECHE, what is the median value? So what you think is really the median, that is not the average, as you know. And then I ask you, what is the 25th and what is the 75 percentile? So, of course, I cannot summarize the entire process in few slides, in few words, but just to let you know that this process, expert knowledge elicitation, there is a vast experience, and there are several methods, official methods that are used, like the Sheffield methods, the Koch method, and EFSA, among these methods, use the semi-formal ECHE. So I will not enter in detail on this, but just to add a few words on the methodology. So the methodology of the ECHE is run in a way that every member of the working group, when there is the elicitation, express his own value without being influenced by the other. Then there is a session when the value expressed by the individual are discussed and a consensus is reached. A key role is the role of the elicitor that help the discussion and help the reasoning and helps the expert to be familiar with the metrics. Of course, you cannot start from scratch. The working group should be trained a bit, at least with 1 or 2 training, and then the methodology can be applied. As I was telling you before, we want to express in reality, we will express the probability distribution more than one number. So, as you can see here, what stays between the first percentile and the 99 percentile is the credibility range. That means that the values that are within this range are, let's say, credible. And of course, the more information are available for the expert and the higher is their expertise, this estimate, the probability distribution is narrow, is more, is not very, is very centered on the median. While if for several reasons there are a lot of uncertainties, because for instance, we don't know. Now let's make the example of the pest, estimate of the pest likelihood in a consignment. If we have uncertainty on the pest pressure at the origin in the country that is exporting, we have uncertainty on the efficacy of the mitigation measure. We have uncertainty on the sorting of the product before exporting. Of course, this can result in a very broad range of value. While on the contrary, if we have very good information on what is the pest pressure at the origin, and we know that the phytosanitary product like the pesticide application are super effective, so we can reduce this uncertainty quite a lot. Okay, with this this super fast pill of API, I give the floor back to Monia.
Thank you. Yes, this. Okay, so from here, I'm going to show you some insight from the 5 years of CRA activity. So far, as you can see from some numbers, EFSA has published 71 scientific opinion on commodity risk assessment, coming from 22 different countries and spanning in more than 80 plant species. Oh no, don't worry. And yeah, there is
I don't know because it's not complete. There are 2 numbers that are not appearing. Sorry, Monia. I don't know why.
Yeah, the thing that is missing, yeah, it's okay, but I just say so. But we will see also in the next slide, so no problem. And yeah, the number that you can see here is actually the 483 pests that have been selected and evaluated for their likelihood of entry in the EU country. Okay, so I ask you for the next slide. Thank you. So yeah, this number in fact came from a total of 126 dossiers received so far and processed. Some of them, as you can see, have been also discarded, and some are ongoing or adopted, so are in the phase of being published. And the next slide, please. And the dossiers mainly originated from Europe, with high number of dossiers receiving from UK, actually. That is raising a lot the numbers in the statistics, let's say, followed by also Ukraine, Serbia, Moldova, or also from America with Canada, US, or Costa Rica, or from Oceania, also received from Australia. So next slide, please. Yeah, this figure, for example, illustrates the progressive filtering process applied in EFSA commodity risk assessment, and starting from a very large pool of more than 50,000 pests analyzed, it is reduced about to 17,000 and unique pests. And from these, around 15,000 are identified as non-EU regulated. And a major reduction occurs at this stage, as a large proportion of pests are excluded because they are either already present in the EU or not relevant for specific commodity country combination, as I was explaining in some slides before. And only a small fraction of the initial pool progresses to the final stage. And this led to 255 actionable pests, representing those requiring further consideration, and 228 pests are included as in the reserve lists. That, by definition, the reserve lists are those pests that are potentially associated with the commodity, but not fully assessed due to insufficient information or uncertainties, and therefore not included among the actionable, but pointed out. Next slide, please. In this slide, you can see that among the taxa that have been selected and assessed during the CRA, insect clearly are the largest fraction, accounting for the 58% of the total, and followed by fungi that represent the second largest group with 21%, and followed by viruses with the 8%. Next slide, please. I just show some very quick insights about the distribution of the screened pests, because let's say that although a large number of pests, so just recalling the concept of before, are initially associated with each host commodity, only a subset meets the key selection criteria, so the dark blue one. And looking at the third country within the European area, such as Serbia, Moldova, Ukraine, non-quarantine pests are not usually or not often ultimately selected. And this could be explained because the majority of the already European areas, because they are already inside the European area and therefore do not meet the inclusion criteria, because maybe they are more than three European country. While if we move to a broader and different context, such as China, the number of actionable pests that go below the non-quarantine increase. This could reflect the fact that the pest might not be present in EU, but but in China, yes, and this is mainly could be also because of the geographical or environmental factors that, of course, change a lot. And next slide, please. And in this case, it's recall the previous slides also in this case. Just give again the fact that the pest species that are the biggest one. So the from the big pool at the end, you will have a later number of those that have been selected, and also in this case you can see the differences between the area that belongs to EU countries, so Europe actually, not EU, and the differences between the one that are outside in the number of pests selected. And so next slide, please. Yes, and in this context, for example, of the total pests selected so far, so from the 51.5% that correspond to non-regulated pests, among these, the 57% have been subjected to the pest categorization. And so just recalling the concept of before, and then among them, the 93% fulfilled the criteria to be considered as potential quarantine pests. And this consideration would be taken, of course, on board by EUCOM. So next slide, please. So linked to this, in fact, the CRA could be instrumental to recognize possible potential quarantine pests that can be subjected to pest categorization and ultimately to pest risk assessment. And as I said before, then would be taken on board by EUCOM if those can be fulfill the criteria to be considered as potential quarantine pests. And next slide. A well-known example of those pests that has been so screened, even if they are not quarantine pests, but they've been non-EU, but potentially could be categorized as quarantine pests, is the one of Pocazia statungensis. And this insect, in fact, originated from China, where it was firstly described in the 17th and later spread in South Korea, Japan, Russia, and Turkey. And it was in fact screened through how commodity risk assessment and receiving from China, and then was put into the on board of EUCOM. And even if this is not still a quarantine pest, but it has been classified as by HEPO, and is going to be discussed for potential inclusion, even if it's not included as quarantine pests. Next slide, please. So this slide, in fact, was showing the fact that this pest has been discussed by the EUCOM for its potential inclusion in 2022. And with this, I think that we. Next slide, please. yeah, we think, I guess that we finish it. If we would like to share some other insight, or Ciro want to add anything else? Or
No,
otherwise,
we are available for possible questions, or
yeah.
otherwise, the,
Okay, so yeah, thank you
for
then, yeah. Mm.
so may I okay, these are okay, very last slide to stay in touch with us with EFSA. These are the way of contacting us, and that's it. So I think I can stop the sharing the screen and okay.
Thank you so much, Monia and Ciro. That was that was a lot of information for me to take in early in the morning. But that was incredibly interesting. I was wondering, is there an automation step in the filtering process for figuring out whether a pest could be a problem for a particular commodity and country? Something if you're starting off with 50,000 pests and filtering that through, does someone have to do that manually, or is there a system that I guess would flag those data pairings?
A good question. No,
Yeah.
we do something, let's say automatically, not entirely automatically, the filtering. For instance, all the process, okay, it would require quite a lot of description, but first of all, how we create this pest list that for some plant species are of more than 1,000. Let's imagine if you start searching the pest of Malus domestica at the apple species, and you search on the various databases and on literature, you got this huge number. So also the preparation of the pest list has been standardized in our approach. So normally we start with the more common databases that we all know, so EPO and CABI. But this result only a very, very limited number of pests. Then we have to dig deeper using all the thematic database like Nemaplex, ScaleNet, Lepidopteran of the world. There are a series of thematic database that EFSA recognize as relatively in a good shape, I would say, that are maintained, are curated. And at the end of the process, when we have collected a huge number, the number that can be several hundreds, but also thousands of pests, we complete with the literature search, a systematic literature search. So, no, not systematic, I would say, literature search. So, in sense that we run a string that search on Easy Web of Science and on Scopus for all the possible association between, let's say, Malus domestica or apple, using either the scientific name, the common name of the plant, and all the definition of a pest. So with this last step, we collected some additional, not so many pests. And so we have a bunch of, let's imagine, 1,000 of pests. As you ask, is correct, because how we can get from 1,000, then we result in 20. The first criteria that Monia described are, of course, these are the 1,000 pests that can be associated theoretically to apple. But then if the country requesting the derogation is, for instance, Australia, we have to look which one of these pests are present in Australia. And for doing this, we should rely also on other databases that can be CABI, but can be GBIF also, with the GBIF with a very cautious approach, and not only. And then ultimately, if we have a doubt for some pest, we approach the NPPO for asking, okay, to us it resulted that, I don't know, Pocatia shantungensis is present in Australia. Can you confirm? And so this is the ultimate verification to say that is present there. Then the other criteria is which one of these 1,000 pests is already present in Europe. And in this case, we don't care, because if they are already there, can be excluded. So from the matching of these three criteria, pest should be present in the exporting country, should be absent in Europe or limited distribution or quarantine. And then the pest should be a real pest, so it should cause an impact, and the pest should be associated with the commodity. As Monia said, if we are importing cuttings and the pest is a root pest, we don't care. So we check all this. Some of them is kind of automatic because from CABI we have a database of distribution of pests in the world, so we can, using the vertical lookup function in Excel or other function, we can do a semi-automatic matching. But of course, then we have always to double check. Your point is key because, of course, if there would be the possibility to, especially with maybe artificial intelligence support nowadays, but also other tools, if there would be a possibility to speed up or automatize this step, can be very, very helpful. And we are exploring this possibility, of course.
Thank you, because yes, I was thinking that just sounds like so much work. I mean, it's a huge project either way, but if there's a way to be able to match this data to this data, for example, without someone having to go and manually, you have to verify, of course, but oof.
Yes, also because sometimes maybe in some literature and in some articles published, maybe you can find that they actually find the associations. Of course, you need to go deep into the read of the article. If, for example, they describe several species of both plant species or plant pests, so you can find in one article more information that maybe are not still reported in other database. So always a double check of all the measures that we do have. It's key.
Sounds like possibly the most intensive literature review I've ever heard of. Incredible. Oltan, Connor, did either of you have any questions?
I do, if I can come further, Jess. Okay, thank you. Thank you very much, Ciro and Monia. That was a very good overview of the EU process, and we all know that's not a very easy thing to do in a very concise time. So kudos to you for getting that across. I think you did quite well. You did mention, Monia, that if a pest is present in more than 3 EU countries, I think it's excluded if it's found, the commodity risk assessments. That means it's considered present. Is that always the case? And I just wonder if, how many pests that are found to be present in 2 EU countries, do they generally get accepted for quarantine status? Because that should come as some surprise to EU member states to have a pest present for who knows how many years and not consider it, and then all of a sudden find it's a quarantine pest and requires quarantine actions. So I think there's quite a bit of discussion to be had there, and they must be quite difficult for those marginal pests. And you mentioned Picasia. I imagine when Picasia came on the radar for the EU, it was only present in maybe 1 or 2 EU member states. It's under consideration, but it must be present in 4 or 5, maybe 6 now. It's very well distributed, I think. So does that change the dynamic in the discussion? Does that automatically preclude it from going forward for quarantine status now, given that the time period has moved and the pest has spread? So thank you for that anyway. That's just one general consideration and observation that comes across.
Yeah, of course. For example, if a pest is already a quarantine pest, if it's present in EU in 1 of 2 or 3 countries or more, of course, we still keep this pest because it's a quarantine. As you said, it's a key point because, of course, in some cases, 2, 3 or equal to 3 member states can be still tricky to understand. And we were taking each pest case by case and analyzing case by case. And as Ciro said, in some cases, also when we were not sure about the presence or the widespread on how the member state is acting, EFSA can contact also the member state and ask, is there any issue with this pest? Are you taking some action against this pest? Should be aware of some more information, and this could be then weighted between the expert how it's possible to proceed. This is why there is also the pests that are included are, as I was saying, as in the not as actionable, but in the list of reserve list, that like we should take an eye on it, even if there are some uncertainties on its presence, or in other kind of uncertainties. And I hope if Ciro wants to add something.
Yeah, no. Thanks for the question, Connor, because exactly as you said, I have to say, first of all, the pests that became actionable in the commodity risk assessment are not automatically considered quarantine, are actionable, and then it means that the next step is the categorization. So if also the categorization say, okay, we check all the criteria to be potentially quarantine, they are candidate, but then there is the discussion of the path, and then many countries can raise the point that you correctly mentioned. But even before our expert, we have some expert very pragmatic and that you probably know, Connor, is Royal Potting. That is so in some cases our expert, they know that maybe a pest is present only in two countries, let's say Greece and Italy, but the pest is present since maybe 20 years and nobody take action. So they say, okay, it's true, the pest is only in two countries, but never represented a threat. So just keep it. But these decisions are motivated, no? Because when we publish the opinion, we publish also the entire Excel. So someone can say, okay, but why you excluded this pest that was only in two countries? And so we try to give always the more transparent reasoning that we can give. And then, and I have to say that at one point from this activity, we were feeding the PAF and the Commission with a lot of categorization. And so there was also a concern among the EU country to say we should be cautious to not brought too many pests to the quarantine status. So these issues are definitely taken and considered. But it's important, I think, that at least this exercise helped to do some horizon scanning, let's say, a kind of horizon scanning.
Thank you so much.
Indeed, thank you. Sorry, Jess.
I'll just think, in the interest of time, do we have any other questions? Obviously, knowing that Ciro and Monia are available via email for any questions we might have later on. Okay. Well, thank you so much, Monia and Ciro, for this webinar. It was absolutely fascinating, well worth getting up for. And thank you, Oltan and Connor, for coming along. We did also have Frank earlier and another person, but I imagine it's just gotten a little bit late. That's all right. Well, thank you so much, everyone.
Thank you to you.
Thank you. Thank you very much.
Thank you.
Bye. Have a nice evening.
Thank you, and have a nice
Good evening
or a nice day in your
afternoon.
case. I hope you can sleep a little bit.
Me too. Thank you.
Ciao.
Buonasera, Ciro. Monia.
Buonasera. Ciao. Ciao.